Today we're going to learn a method to find the coordinate of the vertex of a quadratic. So for the warm-up, draw a point on the vertex for the following quadratic equations. The vertex is where a quadratic changes direction. So for A, the vertex would be a maximum. For B, the vertex would be a minimum. And for C, the vertex would also be a minimum. So here's where it changes direction. So if we graph it, we can find the vertex, but we're going to learn a new method for finding the vertex today. So let's consider this function, x squared minus 4x minus 5. You should be able to calculate A, B, and C. So A is the number next to the x squared, it's 1. B is the number next to the x, it's negative 4. And C is the number by itself, negative 5. And we've used quadratic formula before to get answers. Remember when I've been looking at your work, I've been looking at can you plug in, can you calculate the discriminant, and then can you solve. So they're going to break it up, and they're going to say, okay, from this second step right here where you have the discriminant, if we have 4 plus or minus, the square root of 32 is 6 divided by 2, and they're going to break it up, and they're going to do 4 divided by 2 first, which is 2, plus or minus, and then they'll do 6 divided by 2, which is 3. So that's how they get the 2 plus or minus the 3. So the question today is, how can you use the 2 or the plus or minus 3 to get the zeros of the graph? And remember, zeros are the x-intercepts. So if we take a look at the graph, how can we get that 2? So here's this 2. Right here along this line is 2. And if you notice, plus 3 will give us the first 0 at 5, and minus 3 will give us our other 0 at negative 1. So if we look at this, we have the zeros. We know how to find the zeros, quadratic formula or graphing. But the question today is, how can you use that to find the vertex? And notice the vertex is that 2, and if we go back to the equation right here, here's that 2. It's 4 divided by 2. So if you think about the formula for a quadratic formula, that would be opposite b over the bottom, which is 2a. So this is how we can get the x value of the vertex, opposite b over 2a. How can we get the y value of negative 9? All right, so again, if we get that 2 by taking opposite b over 2a, if we get the x value, we can plug back in to the original formula. And the original formula was this x squared minus 4x minus 5. Okay, so this will be your goal today. Can you solve for x? When you find x, can you plug back in and solve for y? So the steps are written out right here, and we'll do some examples together. So the first step is to find a, b, and c, and that's review. So here a is 1, b is negative 4, and c is 7. And so if we have to find x, it's opposite b over 2a. So the opposite of negative 4 is 4 over 2a. 2 times 1 is 2. So this is 4 divided by 2. So there's the x value is 2. So the next step is plug in to our original equation, which is right here. So when you plug in, use parentheses, we have 2 squared minus 4 times 2 plus 7. And you should be able to just type that in your calculator if you don't want to do the math in your head. So we have our 2 squared minus 4 times 2 and plus 7. So the y value is 3. So this vertex, if we were to graph this, it would change directions at 2, 3. 1, 2, 1, 2, 3. And here's where, well, I could draw that better. Here's where it would change direction. Let's try graphing that and see if we get that as well. So I'm going to go graph this, and so we had our x squared minus 4x plus 7. And there's your vertex at 2, 3. On the calculator, if you want to do it, you can go to Menu, Analyze Graph, and this is a minimum. Go to the left and the right of your minimum, and there it is at 2, 3. Okay, let's try the next one. Again, find the vertex. Where does it change direction? So the first step is A, B, and C. So here A is -2, B is -12, C is -23. Next step, x equals opposite b over 2a. The opposite of -12 is 12 over 2 times -2. We get 12 over -4, which is -3. Now we need the y value. Plug back into the original equation. -2 times -3 squared minus 12 times -3 minus 23. Now there's a lot of negatives and minuses here, so you need to make sure that you know how to type this in the calculator. So let's take a look at what that would look like. So -2 parentheses -3 squared, there's the first part, minus 12 times -3 minus 23. So here's what it should look like when you type it in, and we get -5. So this graph changes direction at the coordinates -3, -5. Again, if we were to graph this, I can go to Scratchpad here, and I'll hit Tab to go up to my graph. If I type in this quadratic, the equation, -2x squared minus 12x minus 23, and it should change direction at -3, -5, and it does. Let's do one more, and then this will be what you practice today. I'm going to get myself more room here. Okay, so we have A, B, and C. -3, 24, 48. And the next part, x equals opposite b over 2a. The opposite of b is 24, or -24, over 2 times -3. We have a negative divided by a negative, and we get +4. So then to solve for the y value, and another way we can write this function notation, I didn't notice that I had that before, we can say f of 4 means plug in a 4 everywhere you see an x. So -3 times 4 squared. So here's another way to write that, what you're plugging in. Plus 24 times 4 plus 48. So we get let's just type this in the calculator. So -3 parentheses 4 squared plus 24 times 4 plus 48. All right, so we'll get 96. So this vertex is pretty high. So where it changes direction would be 496. All right, let's graph this one. I'm going to use Desmo's calculator, which you can download on your phone for free, or look here, because this one's easier to move around the graph than on the calculator. So I'm going to type in the equation. Whoops. Let's go back here. -3x squared plus 24x plus 48. Okay, and let's zoom out because we know that our vertex will be 96. And if you take a look at there, it is 496. So you can see what it looks like on the graph. Okay, so you're going to try these 3 steps on your assignment, find the vertex of each of these equations, and even do the word problem. You should still be able to find the vertex. And we'll go over any questions tomorrow.